All right, this is the lesson on ellipses. I'm not sure how you're supposed to say that, plural. The bookwork on this is on page 698 in your book. And in the notes here, it's on worksheet 5, 6, 7. You need to have out worksheet 7 too if you didn't already take that one out. Just quick review. Again, ellipse is when we cut a cone at a slight angle to the base. Okay. So it says an ellipse is a closed symmetric curve shaped like an oval. Then it has this sentence about the sum of the distances of any point on an ellipse from two fixed points called the foci remains constant no matter where the point is on the curve. All right? We're going to take a field trip to the backboard and investigate that in 1 second. First, I want to finish talking about this. An ellipse is formed by intersecting a cone with a plane that is neither parallel nor perpendicular to the base of the cone. All right, which of those is looking like an ellipse then from the pictures I just showed you? Or from the description right here, shaped like an oval. So the choice, you don't have this on your sheet, I know, but which of these would you suggest is the right shape? Yes. If I had a cursor, I would circle it. Come on. Okay, that one. Yep, my cursor's still not working.
Oh, we don't have that one.
That's what happened. I know you don't.
Oh,
That.
okay.
No, you're fine. That's what. Okay. Now, this is the properties that we're going to talk about. But before we try to just talk about those properties, I want to show you on the board. And I should probably just pause this because I don't think they're going to be able to hear me from the back of the room. Okay, sorry, we took a little field trip there and we're playing around with string on the backboard, but the idea we came up with is that when we had, here, I'm going to go to a different slide and talk about this for just a second. So I have a slide with the string. When we had, we put our pins or our tape at a focal point, two different foci, and we took the pencil and we made the string go around, we got an oval, okay? When the foci lined up this way, we did the same thing and we got an oval going that way, okay? If we put the foci really close together, we got really close to a circle, okay? Now, back to the properties we want to talk about. I'm going to make up an, actually I'll just use the one that's here. This ellipse right here, we want to examine all these properties, okay? Out on the x, it goes this distance, the square root of that, which is going to be how much? 6. So it goes to -6, 0, and 6, 0. Then underneath the y is b squared. In our case, it's a what? 49. So it goes up how far? B would be 7. So we go up here to 7. Down here to 7. And if we sketch this, is it longer? Mine really bad. Is it longer up and down or across? If I had drawn it very accurately. Up and down. This is a vertical ellipse. It's longer up and down because the bigger number is underneath the y value. Okay. Now I was circling here. Sorry. I think this happened yesterday. Okay. The further numbers away are the major axis, and at the ends of the major axis are called the vertices here. This particular book that I took this out of calls the ends of the minor axis the co-vertices. Our book just calls all 4 of them vertices, okay? So it doesn't matter. The foci are on the major axis, okay? To find the foci, I love this nice little chart here. Does it tell you how to find C? Nowhere on that slide does it tell us how to find C. Okay, if you'll take out your orange sheets, if you don't already have those out. Okay, on your orange sheet, do you see the lovely sticky note that I Xeroxed on there for you? That's where it says ellipses at the top of that page. It says characteristics of ellipses. Everybody find it? It's the one that has a sticky note on it. It should look like this on the board. All right, it says, this particular one says if A I'm sorry, if A is the bigger number, then it goes this way. If A is the bigger number on this picture, it goes this way. Okay, in other words, it's vertical. If the bigger number is under the Y, if A, the bigger number is under the X, it goes horizontally. But this one does finally tell you how to find C, okay? It says the foci are inside. When we did that back there, the foci were always inside the ellipse, right? And to make them be closer in, you have to subtract a squared minus b squared and then take the square root. It kind of looks like Pythagorean theorem, but it's a subtraction, right? Okay? And then we're going to square root and find C. All right, while you're on that page, I want to point out a couple more things. The properties here, some of these are cut off on your reference sheet by my nice little sticky note. I don't think anything important is covered up, but just so you know, the properties should say that the foci always lie within the ellipse. The major axis will contain the foci and be determined by whichever denominator is larger. Okay, if it's underneath the X, it's going to go in the X direction or horizontally. If the bigger number is underneath the Y, then the bigger axis or major axis will go vertically on the Y. Today, everything we do is going to be centered at the origin. So these are the easy ones. A couple days, we're going to practice when they're not at the origin anymore, and then it gets a lot more complicated. Not hard, just a little more complicated. All right. If C is the distance from the center to the foci, to one foci, then 2C would be the distance between the foci. They're going to ask some questions about that on one of the worksheets. The distance, the length of the major axis would be 2A, and the length of the minor axis would be 2B. Does that make sense to everybody? Okay. The center is the midpoint between the foci or the midpoint between the vertices. Seem right? The center's in the middle. We good? And again, this formula, c squared equals a squared minus b squared. That's how you find the foci. All right, the other place that this packet talks about ellipse, you do have this. It is on the front page of the other sheet, or it's on the other sheet. It says transformations of ellipses. And the first part there, okay, is this exact chart. Does everybody see where that is? I just want to make sure you know where this stuff is on your, okay. Underneath that is a big old one about translating the ellipses when they're not at the center anymore. That's the fun we're going to have later. But you will notice at the bottom, it finally does say c squared equals a squared minus b squared. Everybody see it down there at the very bottom? Okay. So it is there. It's just not up here by the ones about untranslated ellipses. It's only on the ones about translated. All right, wait, we didn't finish. Let's find the foci on this one then. It didn't ask us to, but we're going to. What's the bigger one here? 49. So a squared is 49. It's already squared. B squared is 36. So a squared minus b squared would be what? 49 minus 36. Anybody helping me? Okay, that's 13. So c is the square root of 13. So if we went out square root of 13 and square root of 13, now square root of 13 is a fairly small number, 3 point something, a little over 3.5 maybe. That's not out to the 7 here, right? The closer it is in, the more circular it is. Was this one more circular? Yeah, it was only 7 and 6, right? Going one way, major axis, 7 each way, minor axis 6, so it was pretty close. All right, let's try some more of these. Problem number 1 says, what is the equation in standard form? All right, you know me, I have to graph them all. This says we have a vertex at 0, 5, not a co-vertex, but an actual vertex at 0, 5. So over 0, up 5. Where would another vertex have to be? Yes, at 0, negative 5, as long as it's at the origin. And it has a co-vertex at 2, 0. So where's another co-vertex? Negative 2, 0. So can you write the equation right now? Can we skip all this garbage? Is it a horizontal or vertical? It's longer going up and down, that is vertical. Okay. The distance along the major axis is 5, so our a squared will be 25. Co-vertex was 2 out, so b squared would be 4. Now, this is a total typo on their part. Can you have 2 equals in one equation? No. And this form is not y equals anything, okay? This is the equation. Copied that right off their online book, and it's totally wrong. All right, this is that the form should look like. What number goes under the x, guys? How long did it go out on either side? 2 squared, which is 4. On the y, it went up 5 and down 5, so this is 5 squared or 25. It's a squared and b squared. Doesn't really matter which one you call which. They like to call a squared the bigger one. Some of them do, okay? But it's the one underneath the y, because it was longer in the y direction. Better? Getting there? Okay. Is this the next page that you have? This is 5B. This is just notes. It says 2 different types of ellipses will have their center at 0, 0. When the foci are on the x-axis, then it will go horizontally. Okay, so x will be the major axis. And the vertices will be at plus or minus a, 0, and the co-vertices at plus or minus 0b. The next slide, I think, has the foci are at C, and you determine C by this equation again. The other kind is a vertical ellipse. It says the y is the major axis, and the bigger number will be under the y value. So the vertices are at 0, plus or minus a, and the co-vertices here or the ends of the minor axis are at b, 0. And the foci are on the major axis always at 0, c, and 0, negative c. All right. Can you pick off 7A? Did you pull out 7A? I'd like to do one problem with you. Pick a problem, 1 through 6. Anybody? 1 through 6. Is it not 7A? Is it 7B? It's 7B? Sorry. I thought I have it up here as 7A. Okay, 7B. Pick one problem. Number 5. Okay, here we go. On number 5. The form says it must look like this. What do we have to get? A 1, yes. We have to divide everything by 25. This number has to be 1. So we're going to divide by 25, divide by 25, divide by 25. 25 divided by 25 is 1. Y 1 divided by 25 is 1/25, or the 25 stays in the denominator. 25 over 25 is 1. Horizontal or vertical? Yes, you picked another vertical one, okay? Goes up and down how far? On the y-axis. 5. So the vertices are over 0 and up or down 5. Can we fit it on here? Just barely out at the ends. You can count by 2s if you want. Just label the vertices so that it's somewhat to scale. And where are the co-vertices, as this book calls them? Or the ends of the minor axis? Yep, the square root here. So plus or minus 1, 0. I think you said that backwards, but I knew what you meant. Okay? Right, that's what it looks like. What is the other thing the directions say we have to find, though? The foci, yes. So, which axis are they going to be on? They're always on the major axis, so they're going to be 0 and plus or minus some c value. How do we find c? Okay, a squared minus b squared. Now, which of these, do we have to square these? These are already a squared and b squared, right? The biggest one is just always the first one. So it's going to be 25. It's already squared. It's 5 squared minus 1 squared equals c squared. So we get square root of, or 4 square roots of 2 square roots of 6. Yeah, don't ask me. Which is almost 5. Anybody tie that to anything we've talked about today? If it's almost out here at 5, 2 square roots of 6 and negative 2 square roots of 6 are the foci. Remember what I said? The further apart they are, the what? Yeah, the more skinny, oval, whatever you want to say. Okay, the closer together they are, the more circular it is. This one is very long and skinny, and the foci are very far out. Okay? Any questions? All right, I'm going to go back and talk about problem number. Actually, I'm going to do one out of the book. I want to talk about this one. Let's graph it, and then I want to talk about how to graph on a calculator. You don't have this. So if you could put this, what's that page we just were doing the notes on that had nothing for you to write on? That one, 5B, okay? Find a little space on 5B to do this problem. We need to divide everything by what? We're going to learn to graph one of these on our calculator. Okay. That you do not have this problem, I'm asking you to write it down on 5B somewhere. 4 goes into 36 how many times? 9. 9 goes into 36 4 times. 36 divided by 36 is 1. Does this look like something that we should be able to graph fairly easily?
Yes.
Okay. Is this a vertical or horizontal ellipse? It is horizontal this time because the bigger number is under the x. It's going to have vertices where? Yes? Square root this. Okay? So it's going to be plus or minus 3, 0 because they are on the x. The co-vertices, as our book calls them, would be up and down 2. Very good. You even got the 0 first and then the plus or minus 2. Okay, so we can sketch it now if we want. Whoa, really bad job, Hofbauer. Okay, the foci. Okay, what are 9 and 4 representing? Yeah, a squared and b squared, already squared. Okay, so a squared minus b squared equals c squared would be 9 minus 4 equals c squared, so c is square root of 5. Which axis are they on? The x, negative square root of 5, 0, and positive square root of 5, 0. All right, it says we are to now graph this on a calculator. We can only graph things in what form? Y equals. Guys, please stay with me here. How can I change? I could go with the original one here into y equals form. 9y squared equals, what would I do first? So 36 minus 4x squared. Then what would I need to do? Divide by 9. Okay. I'm not going to bother to do anything with that. And then I would need to do what? Square root. I'm going to be lazy and just type it in just like that. In my big square root, I'm going to put parenthesis 36 minus 4x squared divided by 9. What could I simplify and what can I not simplify? Can I simplify the top? No, because of the subtraction, I can't make that 6 minus 2x or something. Could I square root the bottom? Because it's just a square root of 9 down there. We could, but I'm not going to mess with it. I'm just going to type it in. If I type this in, am I going to get an ellipse?
No.
Why not?
Only got half of it.
Oh, somebody's way ahead of me got half of it. Why did you only get half of it? Somebody said it.
You can't get negative under the square root.
Yeah, it has to do with you can't get negative under the square root, Caleb said. So we need to do in y2, does anybody know what we need to do? When we square rooted, we should have done plus or minus. So in y sub 2, if you want to see the whole thing, you're going to have to do negative square root of 36 minus 4x squared over 9. Do a zoom square. Yeah, it depends on your window whether it will even look like it actually touches the line. Oh, I forgot the parenthesis. Okay, if you have an older one, zoom square. If you have an older one, sometimes it will need some extra parentheses possibly because there's the radical. Okay. I could zoom in on this if I wanted to try to make it bigger. Anybody not getting it to work? Let me help you. I did a zoom in to make mine big. Anybody remember the more fun way to check these? Yes, somebody said it.
Go to that website.
What is it called? Okay. Guys, remember, please stop. Remember, on here, we could actually type it x squared over, was it a 4 or, I don't remember what we had. What did we have? 9 plus y squared over 4 equals 1. How's that? Nice, huh? Desmos.com, that's it. Spelled DESMOS. All right? So if you want to check stuff on your homework, there you go. Because these calculators don't have the memory to do that. It takes a lot more power than ours have. Okay. Shh. Problem 2. These will go very quickly if you have these concepts down. Here we go. Problem 2. Good question. Anybody find it? 6A. Thank you. What are the coordinates of the foci? If we have 30, please. 36x squared plus 100y squared equals 3600. What do we need to divide everything by? 3600. When we do that, 36 goes into 3600 how many times? How about 100? 100 goes into 3600 36 times. All right. What is the value of a squared? 100. What is the value of b squared? 36. The bigger number is underneath x, so it's going to be a horizontal. The major axis will be the horizontal axis. Find c squared. Okay, remember, these were a squared and b. Oops, not, I just said it, did it wrong. Said it one way, wrote it down wrong. Okay, that's already a squared. And this is already b squared. So when we subtract, we get 64 equals c squared. So c by itself is, yep, plus or minus 8, which is going to be what we need when we go to graph it anyway. The foci are going to be at 8, 0, and negative 8, 0. So can you do a quick sketch on your paper there? Are they counting by 2s? Right? What's wrong? That's the ends of the minor axis. So they are at the square root of 36, so plus or minus 6. Anybody have a question? Otherwise, I'm going to move on because you guys are just talking.
C equals the foci.
Yes.
Got it.
Anyone need more time? Okay, problem 4 at the bottom. What it... Do you need me to go back? You're sure? Okay. Using the foci, it says, what is the standard form of an equation of an ellipse if the foci are at 0 plus or minus square root of 17? What is this telling us? C is equal to? Okay. The co-vertices are at this, so what is that telling us? Okay? The foci are on which axis? 0 square root of 17 would be, okay? So they are on the y-axis, so it is what kind of a ellipse? Vertical. The value of c is the square root of 17. The value of b we already decided was 6, right? The co-vertices are out here at 6. We don't know where the actual vertices are, right? So this is our general form. Can we fill in anything? Yep, you can. You can. Do you want to do that next? Doesn't matter what order we do it in. What do we know? A squared minus 6 squared equals 17. So what do we have to do? 17 plus 36, which is, so the square root of 53 is A. I don't know what square root of 53 is, but it's between 7 and 8. So up here somewhere. Down here somewhere. Didn't even ask us to draw it. We were just supposed to come up with the equation. That's my worst picture ever. Now what? What goes under the x? 6 squared, which is 36. It's a squared, or b squared goes under there. In this case, it's b because it's a minor axis. A squared goes under here. What's a squared? 53. Everybody all right? Problem 3. This is really important, this particular example, for questions numbered 15 through 17 on 7A. Worksheet 7A, numbers 15 through 17, we'll use this example, okay? So it says, how far apart are the foci of an ellipse if the major axis is 26 feet long and the minor axis is 10 feet long? Do I know if this is a horizontal or vertical ellipse? No. Does it matter? It doesn't. Okay. So you want to make it horizontal or vertical? Just because I want to sketch something. Somebody pick. Vertical? It doesn't matter. If this is 26 feet long, the major axis, those values are at 13 and negative 13. Did I lose anybody? Okay. That's the major axis. So 2A is 26, A is 13. That means this and A is 13. We're kind of jumping around here on their example. The minor axis is 10 units long total. What does that mean? 5 on either side of here? Yes? So the minor axis is 2B equals 10 or B is 5. How do we find C? What's the formula going to say? So which of these equations is right? Right? 169 minus 25 is what? So C is, yes, the foci are at 12 along whichever axis happens to be the major one. We don't really know if it went up and down or sideways. Final question was, how far apart are the foci? How many, Carrie? 12 up to that one, 12 down to that one, so a total of 24 feet apart. Okay, so when you get to that question, you can't remember how to do it, you look back at that example, right? All right, last question, lesson check. I want you to look at this for a couple minutes and think about this. Did the student do the problem right or wrong? If they did it wrong, what's wrong? What is A and B on this this picture, this question? A is 41 and B is 29. So is this the right equation? It's supposed to be in this form.
No.
What's wrong?
It's not squared.
Okay. It should be x squared over what? 41 squared. I don't know either. I really don't care. Y squared over 29 squared. So what was the error for the students? Yeah, they forgot to square the A and the B. Don't say square root. Okay, square means you're taking it to the second power. Square rooting is different. All right, does anyone have a question? I do have one more example. I don't know if you want to write this down or not, but this is an example of one of the book questions. It really is not any different than something we just did. It's just a little more complicated numbers. It says there are vertices at 0 plus or minus 6 and foci at 0 plus or minus 2 square roots of 6. We're supposed to write an equation. Can anybody start us out? We want it to look like this when we're done. Yes. Elijah said underneath here should be a 36. Is he right or not? Okay. This is obviously the major axis if the foci are on it. It's in the y direction, 36. So we need to find this number. That's our C, right? So C squared equals A squared minus B squared. What is the one other number we know right now? We know 36 goes here, right? Okay. 2 times 2. 2 square roots of 6 times 2 square roots of 6 is 4 times the square root of 36, which is 24, equals 36 minus B squared. Yeah, it's B squared is 12, right? B squared is 12. Do we really even need to know what B is? I guess if we had to graph it, we would, right?
Yeah.
But if we're just writing the equation, it does say now sketch, I suppose. So square root of 12 or 2 square roots of 3. Okay, but come up with the equation. You just have to come up with the equation on the homework. A bunch of them are just write the equation. There are some go the other direction. The homework check on this stuff is painful. I'm still trying to get it to fit on one page because there's sketches and it's hard to fit sketches on there. Any other questions?